Over the last 2 years, I've been working on a project creating an AI to play Yu-Gi-Oh! The trading card game. After many failures, this is the current result that I have. Here is the sample deck list that I had both AIs play against each other. It is a very simple deck list containing mainly monsters and a few spells. There is some strategy needed to play these decks. The first couple monsters you have are beaters. These monsters simply have big attack stats. There are monsters with 2000 attack, that beats the 1900 attack, which beats the 1800 attack. It's very simple to understand. The second type of monsters we have are stronger monsters, but they have conditions. For example, Cyber Dragon has 2100 attack, the highest attack in the deck. But you must summon it with no monsters. Otherwise, you would have to tribute summon it, which usually means you have to sacrifice a monster. Tricky, on the other hand, always requires you to lose one card either by tributing it or discarding a card, but it has 2000 attack card, which beats out most of the monsters except for the 2000 attack monsters. The third set of monsters are removal type monsters. We have Windup Soldier, which is 1800 base attack, but for one turn it can go to 2200 attack, which can attack over any monster in the deck. You have Exile Force next, which you could tribute it to destroy any other monster on the field. The other two monsters are flip monsters. We have Man-Eater Bug, similar to Exile Force, except you have to set it first and it must be attacked into, and Snowman Eater, which has 1900 defense, same effect as Man-Eater Bug to destroy a monster when it's flip faced up, but having 1900 attack means only monsters with 2000 or more attack can attack over it. Your first type of spells are your battle position type spells, Block Attack and Stop Defense. Block Attack can make a monster with high attack into defense position, making them very easy to hit over, while Stop Defense simply removes a face-down monster, usually Snowman Eater or Man-Eater Bug. Block Attack does require you to have a monster to attack over the monster you switched into defense position. Lastly, we have this card. The AI should learn to always activate it. How I train the AI is I use a neural network which simply takes in inputs and converts it to an output, which is a probability of what action or a probability of something it should do. One of the first problems I had to overcome was trying to figure out how to convert a current game state into something an AI could read. As we can see in this example, the AI has a current state which lists all the readable fields it could see. For example, it could see how many monsters are on their player field, what cards are in their hand, and the second part is what actions it could take on the available turn. So if we split these two up, we could have all the current states that it could see as input fields, and all the possible actions it could take that turn as an output field. Doing that, we get this neural network. And how we figure out what actions the AI should take each turn is given each input that the AI could see. So for example, in this example, we could see that our opponent has an Alexandrite Dragon on their field, and on our field, we have a Windup Soldier. So those input nodes are activated, while we don't have a Cyber Dragon in our hand. That node is left unactivated. The neural network then processes all this information, activating edges and nodes in the hidden nodes that we cannot see, but this is how it trains, and it simply activates all its edges and weights until it corresponds to an output. And this output is the probability of what action it should take. Each node represents the weight of what card it should play. In this example, it weighs that it should activate product read 0.5. It is the highest weight out of all of these output nodes, therefore the AI will activate product read if it has it. If it does not have product read, it will look down to the next highest output node. In this example, it might activate Block Attack or activate Windup Soldier, depending which card comes first. Alright, time for the demo. This is running the AI for the first time without any training. As you can see, the AI we are training is on the bottom half of the screen. The top half of the screen is being played by an AI that is pre-programmed to do specific actions. We can see the AI is making terrible moves right now, and it has lost the first game very quickly. We can see in the blue command prompt, the pre-programmed AI has won 88% of the time against the untrained AI. This means the untrained AI has a 12% win rate. Next, I'm going to train the AI myself. In the black screen, we could see that there are prompts given to me by the AI telling me which action for it to take next. It also shows me the information the AI can currently see. For example, it sees that there are 0 monsters on the field, it has a block attack in hand, a man-eater bug in hand, and as well as Tricky. All I simply do is type in the number corresponding to an action and it will perform it. In this case, I decide to set man-eater bug. As a human player, I can quickly play through this game and win fairly easily against a pre-programmed AI. I continue training the AI in this manner for around 20 more games. After those 20 games, I go back and train the AI using a Python script I made. And after training the AI, it has a 91% accuracy. That means it has a 91% chance of doing the exact same action that we've performed. So after training a neural network, we should expect that the AI should do a lot better. Now to actually try the trained AI. And then running 25 games against a pre-programmed AI, we could see our actual neural network AI has won around 56%. I'm going to manually train it for a few more games to see if there are any improvements. In general, it should be able to perform better because we trained it with more data. After playing 25 games against a pre-programmed AI, the win rate is now 76%, and this is around after 30 games of training. And that is what I have so far when building this AI. My next step is to see and find out how to make the AI play against itself, as I find manually training the AI on a modern Yu-Gi-Oh deck will take a very long time, given the fact there are multiple states that you need to take into account for, and playing through each game will take a while. Making the AI be able to automatically train itself will save myself a lot of headache, but this is the issue that I need to currently come over. Let me know if you have any ideas on how to solve this problem. Thanks for watching.